Good afternoon. Very excited to be here. It's my first Hackfest, actually, not then my first time on stage at Hackfest. So, love giving back to the community and talk about some research that I've done for the past 9 months. I have to thank my employer quickly. Everyone's got those disclaimers. My employer did not sanction. No, my employer gave me the time and money to do this, so I have to talk about them on every slide. So, hacking banks, because that's where the money is. My interest, I don't write bank software. I am just a sort of finance geek, in addition to being a tech and security geek. And I had curl, Python, and a little bit of curiosity, and went from knowing nothing about this topic about 9 months ago to telling you everything I know today. And it started with me balancing my checkbook, trying to handle my own finances. Using Quicken, I've got a lot of bank accounts. Some people collect baseball cards. Some of you probably have too many domain names. I have too many credit cards, and I need a way to keep track of them all. So I use Quicken. I don't want to do it myself. I use some software sort of purpose-built for that. And I am security aware, so I have two-factor authentication on all my accounts, of course, as all of you do. And I put in one of my new accounts, and the two-factor doesn't work, or it doesn't let me access my account through this desktop software. Well, I think surely if I drop the two-factor, that's not going to work. Nope, that works. So I got to put in my two-factor on my mobile banking app. I got to put in my two-factor on my web banking app. Why not here? What's going on? Is there some different protocol going on? Is there some different way that this desktop app is talking to my bank? Fire up Wireshark and begin. So Quicken is what the financial industry calls a PFM, personal financial manager. These are some of the big names. Personal Capital, a lot of people use Mint.com. A lot of my friends use Mint.com to keep track of their finances and do budgeting. Quicken's the devil I know. It's the product I've been using for 12 years. I hate it. It's terrible. I don't recommend it. I love to hate it. I sort of swear. I find a bug every single time I use it, and I keep paying them $100 a year because I'm a masochist. So I wish there was something better here I could recommend to you, but as we'll see, the sort of whole ecosystem here I think is a bit broken and needs some radical change. So if you've never seen these products before, I'll just walk you through real quick from the end user perspective. What does this look like? You have a desktop app, and it has on the left your list of accounts, and on the right your list of transactions. Big spreadsheet telling you where you spent your money. You first install this thing, you have to link it with your bank accounts. So it gives you a whole list of different financial products we use. You click on one of them, gives you a list of banks to search for. You find yours. Asks you how you want to connect. We'll get into that. Gives you this box to enter your plain text username and password on a site that is obviously not your bank's. Somehow finds your accounts, asks you which ones you want to track, and then starts downloading your transactions. That's what the end user sees using this PFM software. There's 3 different ways to connect. These are sort of Quicken's terms. Quicken and Intuit, they're kind of the industry leader here, even though there's other products. Web Connect is a fancy way of saying, go to the website, download a file, and then manually import it into the desktop app. Express Web Connect is a bot that does that for you. And Direct Connect, or the OFX protocol, which we're going to dive into, is an actual bidirectional, programmatic, structured query sort of proto-web service that you can use to talk directly to your bank. Once again, in picture form, Web Connect, the middleman is you. Express Web Connect, you talk to an Intuit server, and then it has a bot that scrapes your bank's website for you. And Direct Connect is an actual direct connection between you and your bank. Financial institution here is another term you guys pull you in on. That's the sort of general name for investment, banking, checking, credit card. Instead of just bank, the general term is financial institution. So I'll start saying FI or financial institution from now on, now that you're in with the banking lingo with me. I'll still say bank too, sort of generally, because that's easy as well. When I say bank, I don't necessarily specifically mean bank. I might mean like investments. Other important players here are these account aggregation companies. These are billion-dollar companies. Yodlee's been around for 20 years. They figured out early that this sort of ecosystem was insane. That dealing with thousands of financial institutions, trying to get data in a programmatic way, that they could be a middleman for that and provide a helpful service. They basically provide a single API for client developers, and then do all that bot screen scraping maintenance behind the scenes. So they're screen scrapers as a service, but they provide a nice API for client developers, and then they also clean and normalize the data from all these disparate data sources so that, you know, buying something at McDonald's on your credit card on one bank and buying McDonald's on your credit card on another bank, they look the same when they get to your software. The banks hate these companies. We have bankers. We have some bankers here. They hate them because they look like bots. They're doing legitimate work, but they look like bots, and there's plenty of bad bots attacking the banks constantly, and so it's hard to tell the difference between the good bots and the bad bots. So in picture form, again, now you have your creds going to some web app, which sends them to some web service, which sends them to your bank, all plain text. And you have to believe that each of these hops has your own financial best interest at heart, and that they are competent enough to protect a secret. I am not sure which one is easier to believe. I think the latter is more difficult. So, if you haven't seen it already, let's spell it out. The first big problem in this whole space of your money is a shocking lack of least privilege, one of the simplest secure development principles we have. You have one set of credentials which provide full read-write access to every account at your bank and all of your money. You share these credentials with a number of whiz-bang financial startups and middlemen in plain text. You give them that password pretty much lives forever. There's not even expiration. And what's needed here, what we would do if we were designing this today, is use something like OAuth, a tokenized, application-based access control system where you, the end user, gets to grant specific, more granular privileges on a time-restricted basis to each of those organizations. That's what we need, and we do not have it. So that's the intro. Let's get technical. I want to dive in. We'll look at some actual packets on the wire. I'm going to sort of go through specification, what is possible. Then we'll dive into implementation and deployment, what this looks like in the real world, testing banks. So Direct Connect, or the OFX protocol, is a public specification and has been from the beginning. There's a website. You can download this for free. You can implement it for free. You can grab it on your smartphone right now and read along. It's 650 pages. It's quite complex. NFS v4 RFC is about 650 pages. If you've worked on that, it can do a lot of things. Anything you can do with the bank, they've put into this protocol. So you're checking your savings account, your investments, as I mentioned, but then also write operations, initiating transfers between two accounts at the same bank, between accounts at separate banks, between accounts in separate countries. The protocol supports these operations. It's up to each financial institution to decide how much of this they support. All of them support some subset. You don't have to support everything. The protocol is quite modular. And then in addition to those sort of obvious things, there's a bunch of weird side things you can do within the protocol. So like changing your password or registering, enrolling to use this access. You can do all inside of this OFX. There's also these things that are obviously sort of meant to help transition a bank from an old paper-based world to a fully electronic world. Like you can download a JPEG of your printed bank statement through the protocol, or you can have bills from third parties sent to you, again, as like PDFs through the protocol. Also messaging, you can pass messages back and forth, just like when Facebook added their own messaging inside. The OFX protocol added their own email inside of the protocol so that a private channel between you and your bank. On the wire, I said it's a proto-web service because it was first invented in 1997, before REST existed, before JSON existed. They were tunneling over HTTP in a request response, very web service way, but without all the standards and sort of guidelines we understand in 2018. So here's a real request and response. The only part of the HTTP request that's interesting is there is its own content type, application X OFX. An OFX server is usually defined by a specific path on the URL. Remember CGI? That's what this is. And then the user agent, some servers restrict the user agent. So here I'm using the Intuit user agent, the same thing that Quicken claims. Ooh. I've gotten rid of the HTTP headers, same packet. We're just going to zoom in to look at what OFX is. It has this header portion. That's after the HTTP header. It's mostly static, so we don't worry about it too much. But it's where you specify the version number from both client and server. And then here on the left in the request is user ID and password, sending the plain text password every time, like HTTP basic auth. The FI, sometimes you have to specify what your bank ID is in your bank organization. Sometimes you don't. And then you get back a success message and then some data in this sort of XML-ish format. This is actually SGML, which came after HTML. When we knew we needed something a little more structured, but before XML, before we got very rigid on parsing so that you couldn't put in weird input. You can tell it's SGML because your span elements don't have closing tags. That's kind of the telltale sign. You get block level elements which do have opening and closing tags and span elements which don't. So again, on the wire, typical conversation. First thing a client ever sends is what's called a profile request. You can do that with anonymous credentials, and you get back a bunch of information from the server. This is where they're negotiating. What capabilities do you support? What do I support? Then, as we saw with the client, you'll send your real username and password with an account info request, get back a list of accounts, and then send a statement request with your account and get back your list of transactions. It's pretty easy to follow. Here's that first profile request. You can see it's a prof RQ. Coming back is a bank message set, which sort of implies I support banking. I can give you checking account information. I can give you savings account information. And a X for prof, which means I support transfers. You can transfer money internally between accounts. So this profile request, just the existence of these elements implies the capabilities that server supports. In addition to the capabilities, you get some interesting info in this profile response. You get this information on the address, on phone number. This is 1997 when this is first thought out. A lot of banks don't have websites. It was sort of thought that this protocol and your desktop thick client might be your only access to the bank. So you get contact information this way. 1997, 102 starts. This whole endeavor was a joint project between Microsoft, Intuit, who made Quicken and QuickBooks, and a company called CheckFree. Microsoft and Intuit had clients. They had a vested interest in selling those clients. CheckFree had servers. Assumedly, getting banks to implement even one of their proprietary protocols was hard enough, so they joined forces to make this single open protocol that everybody would speak, which is great. It was a great idea at the time. 2006 comes along. The U.S. federal government, same branch with the FDIC, says, hey, we have customer information online. We should, or you, banking organizations, should support multi-factor authentication. Not a must in RFC terms, but a strong should. So the protocol got revved, 103 and 203, which is the same functionality but in XML, and added MFA, which we'll get into. 2017 comes and the protocol is still actively developed. OAuth gets introduced, 2.2, new things. This is good news. Just 9 months ago, November 2017 was the latest rev. There's a big gap here. 11 years, right? 2006 to 2017. What happened? Microsoft stopped selling Microsoft Money, their client app. I don't know why. Maybe it wasn't profitable enough. 2009, they stopped selling it. Intuit's the only game in town. Quicken's the only game in town, and they just stopped caring. They just stop innovating. They start charging their annual fee, and nothing changes. I haven't done a binary diff between like Quicken 2011 and 2012, but I bet it's like it fits on a single page what changed. So it's unfortunate. Competition, of course, loss of competition, we lose the incentive to innovate. But what did happen, good news, is there's this whole homebrew community. People loved Microsoft Money. There was like forum posts, like poetry about goodbye Microsoft Money. And geeks, they started writing their little Python scripts and started like binary hacking Microsoft Money, so it would talk to other servers. And this whole little community built up, which started sort of learning about the OFX protocol, and that's what I built my stuff on, was this existing sort of finance geek community who still wanted to get their banking transactions into an app they loved. MFA, multi-factor authentication. Quick review, you guys all know this. Something you know, something you have, or something you are. Choose two factors, and then you're more secure against brute force attacks or loss of password. The script kiddie overseas can steal your password or get it from a password dump, but that second factor gets rid of these account takeover attacks. Very effective. Security community has mostly agreed upon two-step authentication as the name of this sort of 1.5 factor. It's not strictly something separate, but it's an out-of-band channel of separate information. You're very familiar with this. Twitter still uses SMS, a message, a time-based code over SMS. So two-step authentication. This is what the banks are using in general on web apps and on mobile apps. Not true two-factor, two-step, but better than one factor. So what's in the protocol specification for multi-factor authentication? 4 different implementations, actually. The first 2 are security questions. User cred, sort of a free-form field. The bank can ask you a question, you respond. MFA challenge is a hard-coded list of questions inside the spec. Here they are. Mostly things that we realize in 2018 aren't really private information. Not to mention that if you know every question you have to ask, it's a lot easier to steal that and spoof a second factor. Your zip code, favorite color. The other 2, more promising. Again, we're talking about the specification, what can happen. Auth token is this server-generated static string. It sends it to the client. The client has to. It's supposed to send it out of band. The client has to provide it. That's like the 2-step authentication. No one uses this. I haven't seen it in the wild anywhere. It could be used, with SMS codes, but they don't. What banks are using is the client UID. Client UID is the client generates some GUID, trust on first use. I'll send this to you the very first time I connect. Bank server remembers that GUID. And then forevermore, if I connect to you, I have to provide that same GUID or you deny me. That's the second factor. Also something you know, also something you made up. Unfortunately, people have multiple machines, like a desktop and a laptop and a phone. The protocol realizes this. You might install your software in 2 places. So it's not trust on first use. It's trust on like your first 4 uses. So, the first time I send you an ID, that's okay. And then like the second time, that's okay too. And the third time, and then we'll stop you. So it's not that useful when an attacker already has your password and can just make up what the second factor is. But there's good news because these are all in 103, that protocol Rev from 2006, and 80% of banks in the wild are running 102. So we don't have to worry. We don't have to worry about this very poor implementation because it's not even there. 20% is our green number. About 20% of banks at least are on the 2006 version of the protocol. That 0%, that's 2.2, the one with OAuth. Yeah, no one. It's only been out 9 months, but no one is using OAuth. If I lost some of you in the technical weeds, too long, didn't read, someone steals your password, they don't need your MFA token if they just switch to this different protocol or use a different client. So who are these financial institutions running these 21-year-old software? You may have heard of these guys. The big 5. Actually, I'll note that Scotiabank is not on here. I couldn't find an OFX server, but the other 4 have them. Canada's got 30 domestic banks, about 60 foreign subsidiaries or branches, and about 700 credit unions. Not all of them surely are running OFX, but a lot of them are. And all the big U.S. names, too, of course. From Citibank, Capital One, Bank of America, all the way to YOLO, you only live once, Federal Credit Union. This is me participating in bank branch tourism. I specifically flew here to get this photo. It's in California, in rural California. I have a lot of bank accounts. And if there's any enterprising individuals in here, are you ready to start a bank? Jack Henry can help. They sell this financial software. They'd love for there to be more banks. I know there's a couple CTFs tonight, but if anyone wants to just get in a corner and hack together a bank, I'm game. How many banks are there? North America, US and Canada, mainly. I didn't actually find any banks in Mexico that are using this protocol. Depends on who you ask. Intuit likes to say there's 15,000 financial institutions, although that includes sort of every branded product. So like the Tim Hortons credit card from CIBC is considered its own financial institution for their metrics. There's about 7,000 commercial banks. Actually, I think that's a US number only, so about 8,000 US and Canada. The OFX consortium, the guys who put together the spec, they claim there was at least at one time 7,000 people running this protocol. I was able to find about 2,000 on the public internet, and those sort of compressed down to about 400 actual servers, because there's a lot of service providers in play. A lot of OFX software as a service, 100 different banks, all pointing to the same server, and then tenantized. So let's get into that investigation. What did I find? I spent sort of a lot of time surveying the internet. Two simple questions. What financial institutions are running these servers that I know are old, and what software is providing this service? Could have made some phone calls, but I sent GET requests instead. This is the important part to bring up the disclaimer. It's hard to get this software. I didn't have a lab. These are live production servers at Fortune 500 companies. I did not want to even accidentally take one offline or gain unauthorized access. So this was very high-level recon, which should not have failed as hard as it did. What do we do first? Enumerate host. Where do I find these guys? That's what a typical OFX URL looks like. That community of hobbyists was a fantastic start. There's some people who keep databases so that their scripts can talk to them. OFXhome.com is a great place to go to find if your bank has one of these. Also, some various wikis. And then the commercial products, Quicken, they keep their own database. They call it the branding service. It's basically DNS for banks. Put in a name, get back a URL, so you can talk to it or listen in on communication when you're talking to your bank through the commercial products. So I've got a list. I don't even remember my final number. It's in the thousands. It's much more than the actual number of live hosts. And I wanted to ask, so who's still alive? This is an archaeology adventure. Some of these lists are from 2011. Obviously, things change on the server side. So let's just do a TLS ping. I'm just going to make a TLS connection. 232 stale DNS records. The OFX.bank still exists, but there's no server listening. Not an exploit, but okay, you should have cleaned up your DNS. Starting, a little sign of not super tight IT infrastructure. 15 hosts still listing live with expired certs. Presumably still with your customer data on them, and definitely without anyone checking whether they're alive or dead. Big red flag here that these are unmonitored, and we could dive in further. After I see who's alive, these are all web services. Let's just do Web Recon 101. Let's send a GET request and like an empty post request. Server banners, okay. It's telling me it's running IIS. Should configure that more secure. Not a big deal. OFX service banners. This is nice. Okay, so this is the OFX service. I get a version number. I get an exact build number. I get a date and time it was built. More of the same. Build date on the NS API plugin. Anybody notice anything interesting about that date? 2007. All right, we did our web server profiling. Let's look at the OFX server. Let's start talking the real protocol. What's the simplest thing I can send? I want to send a small, minimal OFX payload. Looks like that with just the base tag with nothing inside. Let's send that. Java lang null pointer exception. Okay, again, this is not a 0-day, but you don't handle the simple case parsing. Where are your test cases? We got a 3 for here, sending that same payload. It starts to write the header to the socket, but then stops writing the header to the socket, and then starts writing the body. And there's 2 spaces in the error message showing me it's just going to reflect back whatever I put in that FID field. I left it's blank here. And SQL state 0200. Quick Google tells you that's IBM DB2 database backend. The database error goes straight to whatever middleware, goes straight to the application server, and is passed right on to the client. You can laugh. Yeah, that's. And this is what I was looking for, stack traces. Stack traces with full paths to lines of code on the local file system from an empty post request. Tickling error messages somewhat accidentally. Let's try to get real info. Let's send very valid requests. This profile, I can send it anonymously. Let's just see what real data I get back that's supposed to be there. Long-lived session key. There are some session keys. They're not frequently used. That definitely shouldn't be used when I'm logging in with anonymous. But this server gave me a year-long session key. The profile response is nice enough to tell you what the password policy is, because you can change your password through the protocol. So the client might want to enforce it client side. So this server has a password policy minimum length 4, maximum length 4, case sensitive no, special characters no, spaces no. I'll do the math for you. About 1.5 million combinations. You do 10 a second over an even slow connection. 2 days to brute force the whole key space. Half a day because you'll get lucky and find it before that. Or 1 day. 1 day. Cut it in half. I hear some sighs. Last recon I sent is enumerate the account. I have no real usernames and passwords. I'm going to send the anonymous user. I'm expecting a access denied or a no accounts found. Not even tell me access denied. 2 obvious error messages that should be implemented, and only 2. Request looks like this: anonymous user ID and password, and the account info block to say, give me my list of accounts. And the response is, or responses. I didn't get any account lists, thank goodness, but I did get a whole lot of error messages. Sign on invalid, could not process request, invalid session, general error. This is the exact same very small request to 2,000 different servers. Why are there 40 plus different error messages? How many implementations are out there? How many different configurations? Some of these are obviously leaking through from the back end. So let's go into that. The financial software vendors who are providing these services. Quick overview on how banks do software from a very high level. On the left, you have your core. This is often a mainframe. This is your database, essentially, and your batch processing figures out how much money are in all accounts in the bank at the end of the day. In the middle, you have your middleware, every bank service that you're sort of used to as a customer, dealing with an ATM, doing bill pay, getting your statement sent to you. And then the front end, just the UI, the web, mobile, and OFX API. Every single square in this graph can and often is implemented by a separate software vendor, and then has to talk to all the other squares. You can see the complexity. It's very high. Not only that, but very often these are not individual deployments. These are custom builds per bank. Bank A and Bank B buys from the same vendor, and they have different code running per financial institution. Great for vendor lock-in, but terrible for maintenance, for software abstraction, for testing because of the complexity. Where do I buy this software? There's no shrink-wrapped boxes or apt-get or app store. You go to any of these financial institution websites and it's like, we offer the best solution possible. Here's a phone number, call us. High touch, negotiated in person over multiple month deals to get a solution to provide you your banking software. Some of these OFX servers don't even have names. Like there's not a product name. It's just the solution sold by a list of companies right here. This is Intuit's official list of who you can buy an OFX server from if you're a bank and you want to support one. There's 25 different entities on here, software vendors. I found 9 more in the wild, presumably no longer preferred partners for whatever back-end sort of relationship. So we're talking 30 plus different vendors. Some of the names: FIS and Fiserv are the Microsoft, the Google, the multi-billion-dollar companies in this space. Enterprise Engineering and Q2, they're smaller, sort of upstarts, more recent. I saw them a lot actually live on the servers running. So they were notable names amongst the 30 there total. I have fuzzy data on sort of market share. I gotta parse it out a little bit better. Some vendors, some servers I can fingerprint, some I can't. But this is a good representation of probably like 60 to 70% of the live market now. Here's Fiserv 2 months ago, getting called out on Krebs for having a increment the ID by 1 to see the next account's transfers error. wget is not a crime. This was in the post message, I believe, not in the URL, so it's a little more obscure. Then there's the hosting providers. These may write their own software or run software from the other companies, the Amazon, the Azure of the financial world. And of course, these come up a lot. Actually, a full 2/3 of all the servers that I found live are at a hosting provider. Although that doesn't necessarily mean they're all the same. They can still be running different software, different versions of the software, but they're hosted in a third-party data center. Since I'm only in the front end, I didn't get to see a lot of the back end. I've talked to a fair number of bankers. The back end, it might be as simple as like an FTP batch job to get your financial data onto these third parties. That's why sometimes you can only see stuff from 24 hours before, or it might be VPN straight into their core. Server headers, long tail of different stacks. A lot of Microsoft IIS, again, about half unknown, half telling me exactly what they are. And a whole story of acquisition and atrophy. This happens in tech all the time too, but man, banks love to buy each other and spin out a divestiture and then do an M&A. It's like compilers and debuggers. So if you've been through an acquisition, I've been through 2, sometimes like products get forgotten. The big company takes over and people leave and some software just sort of atrophies. I think that's a lot of an explanation here. This is just FIS, and 4 of those names up there had first-party OFX servers before they were acquired. So the vulnerabilities. Did my big survey, sent some GET requests, showed you a couple of the fun ones. This is not a PhD level math formula, but based on my experience in software development and pen testing, this many technology stacks, implementations, spec complexity over 21 years, it's probably about 250,000 bugs. Everything on the left, we already talked about. I don't have time to get into my bank who still uses my social security number as my username, null values returned, inconsistent input validation, cross-site scripting, both reflected and stored. I know it's not a website, and yet I can get XSS. So I want to give you guys something so you can play along at home. Time for the demo. I did all of this sort of with some hacked together Python and a database. I then took that and put it into a tool, which I'm calling OFX Postern. It's up on GitHub. You can download it right now, and let me show it to you. So we're doing the tool send to organization ID and financial ID. You can find those in those crowdsourced database, ofxhome.com. This is recorded, but I did it just a few days ago against CIBC because I wanted to give you something local, and I thought they're big enough that they wouldn't mind if we scan them. If anyone from CIBC here, come talk to me afterwards. So the tool does everything I've shown you already. We're just going to run it. It's going to do those GET requests, those very simple, anonymous HTTP GET and POST requests, and then analyze them the same way that I did manually. Scroll back up at the top. You see, just keep a status while we're running. It goes pretty quick, actually. Post, GET, profile. Do some fingerprinting, and then run some sanity tests. Print out that profile data from the institution. Make sure that's the right one you wanted. This is actually the U.S. Branch of CIBC. They're the ones that have the main OFX server. Version 102, of course. No MFA. Capabilities printed in a nice format for you. Banking, transfer between accounts, bill pay, messaging, lots of attack surface here. They do say they require client ID, which is interesting. I haven't had a chance to dive into this because that'd be like a hybrid protocol. They're claiming they're the old version, but maybe they support version, part of the new version, which, of course, there's going to be like made up dot versions of the protocol in the wild too. Not able to figure out via fingerprinting HTTP server, but am able to figure out what their software is. We'll scroll down here quick. FIS, Metavante product, that's one of the acquisitions, I think 2009 or 2006. They were a big player in the space. They're still a big player, but owned subsidiary now. And then we run the same tests. This list is growing. I'm still working on this. Here we see they got that cross-site scripting problem. The post isn't so worrisome, but they're returning text HTML as their content type instead of the OFX content type. No MFA, password policy. You can have 4 characters. Did well on the other ones. I got the framework. I'm adding tests sort of as I go, as I'm testing new services, and pull requests welcome. So, what did we learn today? OFX is your bank's digital side door. Your front door, your web app, your client app, spend a decent amount of security, pen testing and analysis on those. OFX gets forgotten. It's not a backdoor. It's not like an admin-only thing. It's for customers. But it's just people aren't paying attention to it. People aren't investing in it. It's a sad story. The word that I kept thinking of as I was doing this was neglect. Because, I mean, not only these servers, they're put online, people forget about them, but we had, in 1997, a open spec, open to implement programmatic access as consumers to our data. And it didn't require a middleman. It was private. It was between us and our bank, the direct line of trust. And it got squandered. Our personal finances could be so much better today if this trend had continued instead of sort of going into maintenance mode. What do we do about it? There's a lot of blame to go around in the UFX landscape. I'm actually worried that we'll just see a slow decline and death of the protocol and nothing will take its place because there are no other standard APIs to access your bank. But if we wanted to invest, if we wanted to think about the future, if we wanted to do something now, we got to get the biggest client maker to start supporting the latest, most secure protocol. We've got to get all those server vendors to implement a more secure software development lifecycle. And we have to get financial institutions to care about a consumer-based API, not just a web app, but an API for us technical literate, plus all the other sort of startup-y cultures to make apps that help us with our finances. That's the hopeful future. If you're here and you have a part of this, talk to me, do it. Or things will just, maintain the status quo. This is just recon. I touched like 3% of the spec with my packets. Please take this and build off of it. This is one protocol endpoint in a jumble of middleware in a very complex system. There's lots more here to hack, and I'm going to keep hacking on it. Thank you to my employer for paying me the time to do it. Thank you guys for listening. Any questions? Yes.
The people who are working on MS Money, building your Python scripts and stuff, is that, do you think, more secure than what you showed us here today?
Well, they break when TLS breaks. No, the problem is that there's no standardization across the ecosystem, right? So there's these 15,000 banks that consumers want to talk to, and 2,000 of them have a public interface. So you have to go to some consumer, some screen scraping as a service to even get to the other 13,000 that you care about. The hacker code, the open source code, was all individual people writing, individual one-off scripts, and then the people copying them and building off them. So I wouldn't say it's more secure or even actually sustainable if you want to keep track of more than one or two specific banks. Questions? Yes, in the middle.
What do you think of the open banking initiative that's been going on in the UK and is probably coming to North America?
So the UK it's called Open Banking Initiative. It's a government mandated API to do what went wrong here. I don't know a lot about it because my focus has been on this area. I know the 9 largest banks in the UK, they had to implement it. I know they deployed it. I've talked to a few people who are in the know. They say it's a shit show. It's banks being forced to do code they don't want to, and so to even enroll, it's 15 clicks on the website. They're trying to hide it. So it seems like a very good idea from a specification, but doesn't have the buy-in from the people who need to buy into it. And then I'm also a suspect about protocol and a banking system in one country working in another country. OFX was supposed to be international, but there's sort of US-centric ideas all over it. Other questions? Great. All right. Thank you.